Hi, my name is Maxwell Dennison, and this is My Advanced Functions CCT. Today we'll be focusing on the problem question 12 on page 257 of the Advanced Functions textbook. A chemical company is testing the effectiveness of a new cleaning solution for killing bacteria. The test involves introducing the solution into a sample that contains approximately 10,000 bacteria. The number of bacteria, Bt, over time, T, in seconds is given by the equation Bt is equal to 10,000 1 over T. The part of this question that identifies what unit of advanced functions it is from is the equation itself, which is a rational function itself, meaning that this is from Unit 5, Rational Functions, Equations, and Inequalities. The problems we will be solving for this question are A. How many bacteria will be left after 20 seconds? B. After how many seconds will only 5,000 bacteria be left? C. After how many seconds will only one bacterium be left? D. This model is not always accurate. Determine what sort of inaccuracies this model might have, and assume that the solution was introduced at t equal to 0. And E. Based on these inaccuracies, what should the domain and range of the equation be? To start off, we can make this equation given to us a little simpler. We know that with nothing under 10,000, we know it's basically 1. And if we times 10,000 over 1 by 1 over t, it simplifies to 10,000 over t, which can be our base equation. For questions A through C, we will need to remember that B at t represents the number of bacteria remaining, and t is equal to time in seconds. So for question A, we will need to recall subbing in values. The question gives us 20 seconds left. So we need to sub in 20 seconds for t because we know t is equal to time in seconds. Therefore, t is equal to 20 for question A. So we first rewrite our equation, b at t is equal to 10,000 over t. Then we sub in our t value of t equal to 20. So b at 20 is equal to 10,000 over 20. Then b at 20 simplifies to 500. Therefore, after 20 seconds, 500 bacteria are remaining. So now question B is asking after how many seconds will 5,000 bacteria be left? So we have to sub in 5,000 for Bt because the question gives us 5,000 bacteria, and we know Bt is equal to the number of bacteria remaining. Therefore, Bt is equal to 5,000 for this question. So you restate your equation again. Bt is equal to 10,000 over t. You sub in the Bt value of 5,000, and then you cross multiply. So that's 5,000 times t, 10,000 times 1, and that equals to 5,000 t is equal to 10,000. Then you divide both sides by 5,000, and that gives you t is equal to 2. Therefore, 5,000 bacteria are left after 2 seconds. Moving on, question C is asking us, after how many seconds will only one bacterium be left? So we need to sub in 1 for Bt because the question gives us 1 bacteria left, and we know Bt is equal to the number of bacteria remaining. Therefore, B at t is equal to 1. So we restate our original equation, b at t is equal to 10,000 over t, and then we sub in 1 for b at t. We cross multiply, so it is t times 1 and 1 times 10,000, and that gives us t is equal to 10,000, meaning that after 10,000 seconds, there will be 1 bacteria remaining. For D, it is asking for what inaccuracies this equation has for this situation. Assume that the solution was introduced at t equal to 0. So for us to determine what inaccuracies there are, we must graph it. This is a graph of b at t is equal to 10,000 times 1 over t. The inaccuracies of this graph can be seen when t is less than 1 and when t is greater than 10,000. When t is less than 1, the graph shows b at t exceeding a 10,000 value, which represents the number of remaining bacteria. This is inaccurate because the graph represents a cleaning solution that kills bacteria, and what it shows is the number of bacteria higher than the initial 10,000. Past t equals to 10,000, the graph gets very close to, but never touches, 0. This is an inaccuracy because it shows that a fraction of a bacterium is left, yet it is never 100% gone. Therefore, the inaccuracies for this model is number 1, when t is between 0 and 1, the number of bacteria exceeds 10,000, which would be counterproductive for the cleaning solution. And number 2, when t is greater than 10,000, a fraction of a bacterium remains, never reaching 0, which is not possible. And finally, question E is asking, based on these inaccuracies, what should the domain and range of the equation be? So, based on the inaccuracies, we never want the number of bacteria remaining to exceed 10,000 or go below 1. Therefore, to satisfy these numbers, the domain and range must be domain t such that t must be greater than or equal to 1, less than or equal to 10,000, t is the number of the reals, and range where b at t such that b at t must be greater than or equal to 1 and less than or equal to 10,000 such that b at t is a number of the reals. A real-world application for a rational function like the one in this question could be in the business world. Suppose your business produces hardwood floors and you want to determine the average cost of making the hardwood. You could determine this using a function. An example function could be the one shown, h and x is equal to the fixed cost plus cx divided by x, where the fixed cost is the money needed to run the business, cx is the cost of each hardwood floor, x is the number of hardwood floors produced, and h at x is the average cost for making the hardwood floors. A function such as this could be used/made by a personal finance planner for a particular company. Thank you for watching my Advanced Functions CCT video.